Welcome to Tech Tips. Today we are going to discuss ohm testing of a two-wire motor. Why ohms testing? Because it is a power-off test that is safer to do and will give us very good information as to what has happened in the motor. So with that, click anywhere and let us begin. As we are focusing on power-off test, we want to then go to ohms testing. This can be very useful testing, focusing on the motor condition only. There are two types of tests we can do, the first being a winding test. This will tell us directly the viability and condition of the wires inside the motor itself. The second test is a ground test. This test can be done with two different types of meters, and we will discuss both. These tests will prove if the motor ground is still protecting the system as it should. To perform the winding test, access to the motor wires going down to the pump will be needed. First things first though, make sure the power is turned off. Remember, ohms testing is a power-off testing always. Disconnect the wires from the control that go down into the motor. Set the meter to R times 1. Connect the leads of the meter to the wires heading down to the motor. Preferably connect the leads to the motor with alligator clips to ensure an accurate reading. Once connected, we should get a steady number. In the next slide, we will detail how to set up the meter and read the ohms. Meters may vary, but the measurement we need is standard ohms or R times 1. Some meters might actually list ohms spelled out. Some might use the omega symbol for ohms. As well, meters can vary from analog to digital. Analog meters, you need to be aware of the scale you need to read in order to get a proper reading. Analog readings are more open to the operator's interpretation of the number. A digital meter needs to be set correctly. Meters may be marked R times 1, or maybe just have a range of numbers, say for example 200, 2K, or 2 million. Auto-ranging meters also need to be read correctly. An M, for example, means millions and a K means thousands. So a readout of 22.7K is read as 22,700 ohms. When reading windings, you should not be reading in the thousands or the millions. If you are, check your meter or make sure you're reading it properly. Remember, the setting we are looking for is the standard or base setting, or R times 1. Another good piece of advice is to use alligator clips to ensure a steady, clean reading. Using the probes in your fingers will keep you in the circuit and may change the reading, giving us an artificially low or high reading. Here the meter is set for ohms as designated by the omega symbol. This is an auto-ranging meter, and as there is not an M or a K shown here, the reading is in standard ohms or R times 1. Using the alligator clips, we got a good solid number. Now, where do we find the data to understand what this ohm reading means? As you've seen in the slide before, the meter will give you a number. It may range from 0 all the way to OL or out of limit depending upon the meter. All motor manufacturers print in some form the acceptable range of ohms readings for their product. Pentair, we offer the PN793 electronics manual as well as the owner's manual that will have specific information to the product installed or purchased. What we are looking for is the motor winding information based upon the model number of the motor installed in the system. Many times I find it easier to find the information in the owner's manual because it lists only the applicable ohms reading rather than our catalog that would list the entire offering. So what do the numbers mean? Turning to page 17 of the PN793, we find that the two-wire chart is at the top of the page. First, we need a model number of the motor. We will look at the P42B0007A2-01. This is a 3/4 horsepower, 230 volt motor. Looking under the windings column, you will see a range of numbers under the main resistance, yet none under the start column. This is because in a two-wire motor, the start windings are an intrinsic part of the windings as a whole and cannot be measured separately. Now often a question is asked, what if the number is higher than expected? Or lower than expected for that matter? Both would be bad, but they can indicate different issues. Low numbers often mean the insulation is in a weakened state, melted perhaps. That current can flow easily through the system, often potentially to the ground, causing an unsafe condition. So do check the ground integrity. Low numbers often also indicate a heat or a motor running hot issue. This could have been a deadhead condition, poor cooling flow around the motor, or other issues. High numbers mean increased resistance in the windings. This could be a damaged wire, might be gaps, damaged insulation, or other issues. This is often due to an electrical surge or voltage spike. Another question is, it is only a bit out of range, so how much time does the motor have? Can we possibly limp it along? And there is no magical formula or no educated guess for this. Over or under is equally bad, but we have good information to give to the customer, and often this will lead the customer to make a good decision and replace the unit. For the insulation or ground test, we need to set the meter to its greatest ohm setting, typically 20 M or 20 million. A standard meter works well for a ground test, but for a true insulation test proper, a meg-ohm meter is best used. The difference is a meg-ohm meter puts out a range of DC voltage and stresses the system to a limit, showing potential issues, versus a ground test, which is often only 30 volts or less, and will proof a ground issue basically after the fact. If you have a standard meter, that will work good to ensure the ground is safe, however. Setting up the meg-ohm meter by a standard practice is select the voltage 2 to 2.5 times the rated voltage. So, for example, a 230 volt system, we will set it at 500 volts. Once the voltage is selected, press and hold the test button for about 5 to 10 seconds to ensure a good reading. It is also important to note that a motor having any controls or electronics inside it would not be ohm tested with a meg-ohm meter, as this may damage or destroy the motor. And we release the test button and we read a number. So what does this mean? Once again, we have a number, and turning to page 14 of the PN 793, we find the guidelines for ground testing. The real key is the bigger the number, the better. You want a lot of protection for the system to ensure that the voltage does not go where it should not, or more importantly, endanger someone. Often if the windings are damaged, the ground will also show damage. If you find the ground is bad, or suspect it to be bad, do not energize the system for any reason. To review, the ohms test is a power-off test that can quickly be done with a proper meter. Windings and ground tests can give great insight into why the motor might have failed. With the windings test, we have a range of numbers that the windings should be within. Outside that range, remember, low numbers are often associated with heat. High numbers are often associated with a short or potentially a voltage spike. Ground testing, the bigger the number, the better. And remember, if you're unsure of the ground, do not energize the pump. Thank you, and remember to be kind to each other.